Hi, my name is Hauptman, and I'm a fourth year graduate student at the University of California, Merced in the School of Engineering and Environmental Systems graduate group, where my advisor is Dr. Colleen Nannen. I've always been passionate about the environment and about conservation and equitable access to natural resources. So when I joined UC Merced, I started exploring projects with a local reach that would serve nearby communities. My research conducts a geospatial and treatment analysis for 1,2,3-trichloropropane, a toxic chemical and a pesticide that is seeped into groundwater. It is found in 13 states and Puerto Rico, as well as countries in Europe and Asia. TCP has one of the lowest maximum contaminant levels in California drinking water at 5 parts per trillion due to its status as a potent carcinogen. So my research takes a look at the TCP problem from 3 different perspectives. First, I conducted a systematic review of peer-reviewed papers published in the literature, which narrowed down over 1,000 papers to 36 papers, which specifically dealt with how to remove TCP using different technologies. The study concluded that although granular activated carbon made from coconut shells was the most applied and successful treatment, it is costly, produces solid waste, and it isn't as effective as reduction by zero-valent zinc. I then compared different machine learning models to predict where TCP may contaminate groundwater in the Central Valley that can be applied in areas that are unmonitored for TCP contamination to other areas of the globe as well, since monitoring TCP is costly and it's very difficult to test for. So that research showed that hundreds of thousands to millions of kilograms of TCP may have accumulated in the subsurface in California and potentially leached into groundwater. And the machine learning model showed that the most important predictors for spatial occurrence of TCP in groundwater are precipitation, redox state, and nitrate contamination. I also found that the highest model TCP levels are predominantly in disadvantaged communities. The third installment of my research, which is evaluating point-of-use filters and biochar made from almond shells to remove TCP from tap water, found that point-of-use filters have an over 98% mean removal rate. You can see that in this graph here. Throughout the lifetime of their use, and that brand differences between 3 different filters tested were not significant. We also tested the efficiency of char made from almonds and found that although there is some absorption, it is not as good as granular activated carbon and made from coconut shells. However, it has potential and with further development could prove to be a sustainable removal method. Thank you so much for listening.